This is Steam, the largest online video game retailer in the world. Here are some of the pages on Steam of the most sold games of all time. Here we have Among Us, Grand Theft Auto 5, and Forza Horizon 4. And this is my site, a page for a game called The Unwritten Dreaming. The developers describe it as an old-school, single-player survival adventure game and the spiritual successor to the 2012's The Unwritten. The difference between this game and the 3 Steam games I showed before is that this game doesn't actually exist. This game was generated by artificial intelligence. This is a project that I had been wanting to explore ever since I heard about NVIDIA's This Person Does Not Exist, which came out in 2019. This Person Does Not Exist is a site that was created by NVIDIA to showcase their face GAN. I use the same concept in my image generation, which I'll explain more in detail throughout the video. The most important part of any machine learning focused project is the dataset. In my last video, where I used AI to transform beatboxing into drums, I needed to collect and label my own dataset. Luckily for this project, there's an existing dataset created by Nick Davis on Kaggle that aggregates all Steam games released before May 2019, over 27,000 of them. Unless the dataset you're using is tried and true, it generally needs to be pre-processed for your use case. For example, this dataset has way more columns than I need, so I dropped most of them and took the ones that were relevant to this task. For this project, I wanted to be able to generate the name of the game, the developer's name, the publisher's name, the genres, a detailed description of the game's header image, and screenshots of the game. Then I had to actually clean up the input data itself. For example, some of the descriptions contained HTML, which is probably used on the Steam store for some extra markup. Somehow this got into the dataset. To remove HTML from descriptions, I used a Python package called Beautiful Soup, which parses HTML strings. I then realized that some values had extra spaces, new lines, and tabs, so I added a line to remove them as well. It should be noted that this is not necessarily the optimal way of doing this, but it was very quick to implement and it was fast enough for me. This code took less than a minute for 27,000 records. Here's what Half-Life looks like before and after cleaning. Finally, I had to download the images from the links in the dataset. To do this, I used one of the most popular libraries for Python called requests. This library makes HTTP requests a breeze, and I multi-threaded the code to make it a little bit faster. So we have 2 main tasks here, text generation and image generation, each that need their own model. There's a company called Hugging Face, which has a great open source project called Hugging Face Transformers. Transformers are a type of natural language model that have shown to have great performance on historically very complex problems, such as text classification, for example, detecting whether a review is positive or negative, and in my case, what I'm using it for, text generation. Hugging Face Transformers is a project that is meant to make it way easier to use state-of-the-art transformer models. The most popular type of this transformer architecture for generating text is the GPT series of models. For this project, I chose to use GPT-2, which is the most recent version that's open source and available to the public. It's learned in a way to understand and generate text from reading billions of different bodies of text on the internet. The result is a model that, given any prompt, can give probabilities for different words, even names of people, places, and things that it thinks could come next in the sentence. Not only that, but because of this property, it preserves tense and follows most of the rules of English. The coolest part about this is the model essentially learned English without needing to know any of the rules. It just kind of read a lot. So, thanks to the Hugging Face Transformer library, this is all we have to do to generate more text. Here, I'm randomly choosing a sequence of 10 words from one of the game descriptions in the dataset, and using it as a prompt or a jumping off point for the model to generate more text. And this is without even fine-tuning the model to the task that I'm performing. In this case, the way that the model generates text is by referencing the learnings from reading the billions of different random text online and trying to estimate what could be written after these 10 words. So now that I have this model chosen for the task, I'm going to do something sometimes called transfer learning or fine-tuning the model. This is because I'm starting with that already pre-trained model that I just showed before and training it again on data that is very similar to the data that I'm trying to be generated by the model. Fine-tuning is extremely effective for training large models that require a lot of data, especially with smaller data sets. I guess it could be compared to how humans learn new things. When you learn about a new math concept or about a different era in history you haven't studied before, you constantly compare characteristics of each to related things that you already know about. If you're learning a new language, you probably don't start from scratch. You compare it to the structure, the syntax, and the vocabulary of languages you learned before. Something that's important to talk about when trying to perform NLP tasks is tokenization. Most generally, tokenization means turning text into tokens. Now, what that means more specifically depends on the task itself. This is useful because just like every other form of machine learning that I know of anyways, we always need to turn our data into meaningful numbers that can be passed into our model. So I next had to format the Steam dataset in a way that I could use to fine-tune the model. GPT-2 is such a large model in terms of memory consumption and resource consumption that I had to use a cloud GPU provider just to have enough memory to load the batches of training data and the model itself onto the GPU. And in case you were wondering, this project cost me about $40 to train all the models in the video. That's not too bad considering I'm training on an NVIDIA Tesla V100, which on Amazon is listed around $9,000. I decided to go on with training a model that can take different tokens. One for name, game, developer, publisher, description, and genres. This is what some of the data looks like. Now, if I want to generate all the data for a game that doesn't exist, I can feed the model the encoded game token, and it'll generate new data based on what it learned from my dataset. We can generate all the text we need for a video game, but we're still missing images. So if we look at the Half-Life Steam page, you can see that we have the title of the game, which we can generate, the description of the game, which we can generate, and likewise the developer, publisher, genre, but we also have a header image and screenshots. Of course, at face value, I'm sure you can imagine that this is going to be a much more difficult task to generate the images. I created my own GAN architecture, which is very closely modeled after the PyTorch official GAN tutorial, and I trained this model from scratch. GANs are a really cool architecture and method of training deep neural networks that pin two networks against each other. One model, the generator, tries to generate fake data that is meant to look as close to the training data as possible, but it never sees real training data. The other model, the discriminator, learns how to distinguish real data from this fake data that's generated by the generator. The result of this is that, ideally, you have two models. One that's really good at tricking the other into thinking that it's generating real images. Here are some of the best results I got out of the GAN. As you can see, the model learns how to make certain shapes and come up with color schemes that sometimes kind of make sense and don't look totally random, but they still don't look great. Although I do think the coolest thing about these results, and I'm sure a lot of the people that have messed around with GANs in the past will agree, you can actually see that the model is trying to imitate the shapes of text in header images. As you can see, in most of these Steam header images, you have text with the name of the game or something similar. And so this shows that the model is actually learning to imitate these images to, again, try to fake out that discriminator. Here's a time lapse of the model learning to generate screenshots for video games.